Start if everyone wants to take a seat. All right, welcome everyone. Start off, just want to huge thanks to Salesloft for hosting this event. They got the food, the drinks, and the location, which is awesome. Makes our lives a lot easier. So thank you, Salesloft. We got 3 speakers lined up tonight. I'll announce our first in a second, but I just want to do some quick announcements ahead of time. Our next meetup is going to be at Full Story in Buckhead on October 17th. We'll announce that. If you're wanting to speak at that meetup, you can just talk to Akins over there with the beard or myself, or just message us on Meetup. We'd be happy to let you speak. Okay, so let's go and get started. Our first speaker tonight is going to be Alex here from Salesloft. He's going to give a quick talk about K8s, their CI/CD pipeline here at Salesloft. So big round of applause.
Let me get this set up real quick. Pardon me for a minute, guys. Jones, how do I get on this screen here, buddy? Yep, ready to go. There we go. There's the meetup. Sorry, I don't have a vision of that from up here, so I'm trying to see it from over. Oh my. There we go. All right, so we are apparently loading. All right, so what I'm going to talk about today, guys, is a part of our continuous deployment pipeline. It's the tool that actually is the ingress into Kubernetes for our application deployments. We call it K8, which is a supremely confusing name for something that runs on top of Kubernetes. As soon as I get my... any better? Better? Okay. Waiting for my slides here. All right, I'm going to do it that way. I don't know. All right, so who I am, Alex Barnes, as I said, I'm director of SRE at Salesloft. We are hiring on my team for both SREs and looking for Postgres DBAs. So if you're interested, come talk to me or talk to Nora back there. She'll be happy to chat with you about it. I'm also a longtime Kubernetes Atlanta meetup member. So this is my first time talking, so be gentle. So K8, what we're talking about today is actually K8. So what K8 does for us is it handles our Docker builds. It does our deployments of our applications into the Kubernetes cluster itself. It handles rollbacks for any failed applications or any failed application deployments, and also allows us to run commands in those applications in the Kubernetes environment. It's not our full continuous deployment pipeline. It works with our tool called CodeShip that we use that actually is the tool that pulls down code, runs tests, things like that, which then kicks off K8 deployments. What K8 actually is a Sinatra API. It's also a gem and a CLI that we use for automation that interacts with the API. And then we also have a Slack bot built on top of that gem, which is what people like our QA engineers use to interact with K8. So that's how they do their work on the cluster. So it's a simplified interface built on top of that. So the reasons we wrote K8 is we wanted to centralize our deployment logic. We didn't want to do the typical thing of having a bunch of deployment shell scripts checked into repos, all over the place. So when you change your logic, you end up going and updating 50 different places. We kind of wanted to codify that and put it all in one place. We wanted a really simple tool to do that for us. We kind of looked around the ecosystem at the time we were getting started doing this, and you can see in my bullets there, we saw things like Helm, but it really seemed cumbersome. Things like KSonnet weren't around at the time. And it really started as just build and deployment. So we wanted something really slim, so we decided to just build ourselves. We also didn't really want a lot of third parties to have the ability to control the code we have running in production. So one of the things I'll talk about is how we do builds. There are some efficiency changes we could do there, but we control the actual builds ourselves and the actual code that ends up in the cluster. There's really nobody that could influence that, even if we got compromised. That is part of the minimal public surface area. So really, K8, even if somebody compromised K8, they cannot do privilege escalation to get into Kubernetes. They can't run arbitrary workloads in Kubernetes. The worst thing they could possibly do is change the version of one of our applications that's already running in Kubernetes. It's really, small interface. So even if it's compromised, there's not much they can do to hurt us. We really like Heroku's model of, kind of having a tool where you can say, go make this run in my environment, and it just goes off and does some work and comes back and say, okay, I did that. But we didn't want developers to be able to push code directly from their laptop into a cluster. So we have this kind of abstraction layer there where you have to check in your code into GitHub. That kicks off CodeShip. CodeShip runs tests. If tests pass, then you end up in the cluster. So how we use K8 and prod. I'm going to have to walk over here to actually point out some text because that's a lot smaller than my aging eyes can see. So this, by the way, that's St. Catherine. We don't have yeah, the one Catholic in the room, I found him. We don't have a set image for K8, so that's our K8 for for these purposes. So CodeShip talks to K8. So CodeShip here, this is an example of our CodeShip steps. This is the instructions you give to CodeShip to actually handle a given application. This is a really simplified version of it, mind you. But you can see, so the steps here starting at line 2 runs RSpec. So if your tests pass, you'll then move on to deploying into the Kubernetes cluster. Most of this is, controlling, you only deploy for master. There's a name for it. K8 CLI is, again, the CLI for the Kubernetes cluster. That's actually indicating a Docker image. But the command is the important thing here. You see it's K8 deploy example, that being the application name here. And then CI commit ID is just your SHA. So that's saying deploy this version into the cluster for this application. And then K8 URL that has your saved auth credentials and things like that in it. So that's where the actual authentication is happening. And then this is just failure stuff. If it fails, it notifies us in Slack. So that's how our production environment's actually using K8. That is where our applications interact with it. Now in QA, we've got a different interface. I talked about it briefly. I mentioned that we have a Slack bot. So this is probably the most complex interaction people really have with the Slack bot and one command. I don't know if you guys can see this, but this is a pipeline command, which is kicking off kind of a macro of commands for the bot to run against the API. The idea here is that we want to have complex work that can be done against the API without QA engineers having to write a script to do it. It's codified, it's saved on the application, it's been vetted by an engineer. So you can kick off all of this work with one command. So this is doing, you can see here, it's deploying the example app master version into the cluster. Now that is actually an overloaded term. That's actually the build and deployment happening. And then this is running a command against it. This is just the Linux date command, but that can be anything. It's, again, that's saved on the application. It's a codified thing that has to be approved to be, checked into the code repo. And then this is just giving back some status information. When it completes, it ats you back in Slack and says, hey, I've done the work. Like I said, kind of that Heroku feel. I did all this work for you. Hey, it's done. Let's keep working. This all happens in a nice thread in Slack, so it's nice, pretty interface. A bunch of people can be in a room working with it, and it's not polluted by all the conversation. So that's the interface that our QA engineers use to interact with our cluster. So how K8 actually does the build. So this is so a savvy user, one of the first things you're gonna notice here is these are annotations. This is on a deployment, okay? And one of the first things people are gonna ask is, why is this not a CRD? It's gonna be eventually right now. But right now, this is all metadata saved on the deployments. So this is all the important information about how to do a build. So it gives the Git URL, so it knows what repo to check out. This subdirectory is if the code you're building, the build working directory needs to be somewhere other than the root of the repo, change into this directory. Allows you to do an alternate Docker file name, allows you to inject build secrets. So what that is you give it the name of a secret in Kubernetes, and it will actually inject it as Docker build args. So it'll run Docker build for you with build args as a list of secret, values from that secret. So it allows us to store those secrets actually in Kubernetes. So that workflow looks like this. So yet another K8. K8 kicks off a pod. You guys get it? Yeah. So it kicks off a pod that is, we call it our builder pod. So Docker is running inside of that pod. That pulls down your Git repo and is actually doing all that work I just talked about. The interesting thing here is that we're not doing Docker and Docker. We're not actually running the Docker engine inside of that builder pod. We're also not mounting the underlying Docker socket from the Kubernetes node. We do that because of security concerns, because there's kind of some fancy footwork you have to do to allow a Docker container to get network access when you're using a Kubernetes overlay network. We didn't want to deal with that stuff. So to solve that, we have a network load balancer that sits in front of an autoscale group of Docker build hosts. So we actually mount the Docker socket over TCP from a network load balancer. So we have a fleet that we can scale up and down of build hosts. And then that pushes up to our Docker registry that's also running in our cluster. So as you can see, really the theme is this is all very self-contained. It's very closed off. We control the environment very much. Oh God, more YAML. So how K8 does deployments. So I talked about this. This stuff is stored as metadata on deployments. So what an application is, I keep saying the phrase application. What that actually is in our terms is a set of deployments, or rather one or more deployments, with one of them marked an application primary. That's this little label right here. And that application primary is the deployment that stores all of this metadata, all the annotations that actually control how K8 operates. This status right here gets updated when you do a deployment to it. So you say, I want to do a deployment to example app. I want to deploy master. K8 goes and gathers all of your deployments that have that Salesloft app. It changes their image, just the tag on their image to be the version you asked for, so master in our example, and then it changed this K8 app deploy status to deploying. So this one actually, an example, is deployed. This is a completed deployment. So it would be deploying. That's the full deploy phase of it. So from there, how we handle the rollbacks is there's this reconcile loop. There's a loop running inside of K8 all the time. What it's doing is, that's why all this is labeled, so we can gather deployments on it easily. So we look for any deployment that has the K8 app deploy status of deploying. So that means that it's in a changing state. We check those. We say if all of them have succeeded, if all of those have the number of replica sets matching, or rather the number of pods in the new replica set matching our expected number, it's succeeded. We mark that as deployed. If any of them have failed, if one or more of them have failed, we roll all of them back to the previous version. So the previous image is stored here in another annotation. We could have instrumented replica sets and done like rollout undo there. This was just more expedient. It was a simpler solution. We did, because we already have the logic there to do a deployment. So you essentially do another deployment of your old version. So then again, in the Slack bot, I was showing you guys how it can run commands for you. Those commands are also stored as annotations on your deployment. Everything really is. That's why it really should be a CRD. Those are stored here. You see it's salesloft.com/command dot. Now, the way we do this is so when you tell it to run a command, what it does is it looks up your application, it gets all of your config for it, all your images, and it builds a headless pod, a pod that's not part of your deployment, but is using your image and is using all of your configuration values. So it's identical to your pods, but it's not part of your deployment. And it changes the entry point for that pod to be the value of this command. So the pod lives only long enough to run that command, dies, and goes away. It tracks the exit code of that pod to see if it succeeded. And so that lets us do things that you can see here, like run arbitrary scripts, do database migrations, things like that you have to do with a deployment. So that those can be baked right into, if you saw earlier, those code ship stats, it has a migration done in it. It's all one piece. This pipeline is what I showed you guys earlier in the Slack bot. There's some token replacement done there, so you can easily copy those between deployments. Pretty simple. It takes those and then just runs each individual step. So this one will do a deployment, run a command, do a migrate, give you back the status. And that's all I got. As I mentioned earlier, we are hiring. If you're interested in working on things like this, come talk to me, come talk to Nora, Scott, Ben, any of us. We're happy to talk to you about it. We'd love to have you come join us. And with that, any questions? Okay, so when I set up Jenkins, right? Yep. For my deployment, I wrote a shell script. Yep. So it was 2 steps. I changed the image version. I told Kubernetes to go grab it. Yep. And now I've changed environments. My 2 steps are different. Yeah. Can you change environments? Yeah, easily. Yeah, there's a lot of well, I think Scott had an answer there. So you have you would have a K8 endpoint. So say you have oh yeah, we have this fun little mic. So K8 you would essentially have a K8 API that instruments each cluster, right? So you can deploy K8 into any cluster, and it can see across the cluster. There's actually some fancy permissions. It runs in its own namespace, but it can see deployments across all namespaces. So it really, you can drop it into any cluster, and once you put those annotations on your deployments, it'll work.
Are you doing anything to manage locking to prevent QA folks or devs from running a similar operation on the same resources or the same deployment at within the same time frame?
Sure. So we really lean on a replica set to manage that. Because you're modifying a deployment, you immediately get a new replica set. We let the scheduler handle that reconciliation. But really, in reality, that may happen in QA, but in production, that will never happen.
Gotcha.
Only code chip is hitting it. We would have to have some bizarre timing of deployments going out for that to happen.
Gotcha.
Yeah. Anything else? Cool. Well, thanks, guys. Oh,
you got a question?
haha, thanks, buddy. So I have a to-do ticket on my Jira right now to add a K8 bootstrap command that will point at a Git repo, find your manifests, and apply them. Right now, it is you create the deployment. So with like kubectl apply or through the regular Kubernetes API, and K8 will take it from there. But K8 takes over running once you have deployments with the annotations.
Ask him again in late October.
Yeah. Yeah. Cool. Thanks, guys.
While our next speaker is coming up and Alex is helping him get set up, I'm going to stall. But one question that Dennis, he had to leave a little bit early that we generally start these out with is who's hiring? We've heard that Salesloft is hiring. How about anyone else hiring?
Hey, Mark Guillory with a company called Real Cherry. We're a startup out of Georgia, and we're just coming out of about a year and a half's work. We're hiring 5 to 7 engineers, specifically 3 front-end developers, 1 back-end developer, preferably with some sort of PPM knowledge, and a machine learning engineer. And we got space for a couple of others. But yeah, so it's a very experienced team. We're only asking for 5 hours a week minimum commit. Work those 5 hours anytime you want. We prefer you to have a full-time job somewhere else. You can work anytime, 24/7, anywhere in the world. We don't really care. As long as you've got skills, you can check in on the Windows standard. So if you're interested, it's LG, Lawrence Guillory, LG@realtheory.com, or look me up, or I'll be here. But we only work, by the way, we are 100% dedicated only to the Docker Kubernetes stack and the cloud. Everything else, we don't give a shit about. Never ever will. Right. So if you're interested in that, kick-ass. Thanks.
Anybody else? The job market dried up in Atlanta? Surely not.
Oh, I don't know if we mentioned Salesloft is hiring.
This just in, Salesloft is hiring. No.
I'll say the #1 startup. Get in early.
I'll slip you that 20 later.
All right. I will let you do your own introductions, and we'll talk about some secrets.
Right. So, hi everyone. My name is Moshe. That's how it's pronounced, Moshe. Hebrew form of Moses to whoever is interested. I work as a senior DevOps engineer for a company called K8s. We're in Alpharetta. My primary responsibility is around the PaaS platform. Well, PaaS is a platform. So yeah, anyways, mostly Kubernetes. We started doing some stuff around AWS recently. Pretty exciting, pretty interesting. So what I'm going to talk about today is how we integrated Vault and Kubernetes. I assume everyone here knows what Vault is and used it at some form. So I'm really at the highest level going to introduce it. Probably the best product out there right now for managing your secrets. It's got an awesome API. HashiCorp is known for how good their products are. So I'm sure everyone here knows who HashiCorp is. So yeah, just another awesome product of their suite. Yeah, so let me get started with basically the previous situation that we had with, let me start off by saying we run a lot of microservices and a lot of applications on Kubernetes. We use Vault for secrets management because all of our applications, or at least most of them, are they have relational databases in the backend, mostly Oracle, some PostgreSQL. We needed a good way to store our credentials to these databases because we have a monthly rollout of changing these credentials. We don't want to change our code every month just because we changed the password to the database. So what we used to do before we had that new solution that Vault introduced about a year ago is basically storing the access token to Vault as a plain text in the deployment YAML. I don't need to say how insecure that is, even though everything's on-prem and it's on a Git repo, so you can manage the access, who can read the repository. It's still storing password as plain text. I don't need to emphasize how bad this is. The challenge that we had is we want to figure out a way to dynamically generate access to Vault on a need basis. So we created the necessary roles in Vault for that application to access only this set of credentials and these secrets, and that's it. And how we did that is Vault, like I said, version 0.8.3, released September of 2017, so exactly 1 year ago. They released a new version that introduced a feature called Kubernetes Authentication Backend. What that feature allows you to do is to use a service account in Kubernetes to actually authenticate to Vault, generate a dynamic client token that you can enforce a very strict policy on that token. For example, you can have a TTL of 1 second. I mean, that depends on how fast your application is. It can be used only once, for example, and a lot of other rules that, that you want to enforce. So basically what would happen, you're using a service account for each application that you bring up in Kubernetes. It'll go to Vault once, read the set of credentials that it needs to read, and that's it. The access is gone. This token cannot be used anymore. It's purged. So the challenge that we had is, okay, we have that token now. It can be used only once and we can use a service account, but we have 15 clusters. We have a lot of applications and deployments basically in Kubernetes that are running. How are we automating this? How do we avoid changing the code of applications? So what we introduced is something, I guess most of you know, it's an init container in each deployment. That init container would basically, if I'll go through, I don't know if you can see my cursor. Okay, yeah, you can see my cursor. So basically the flow goes like that. We have an init container that spins up before you create your main app container. That init container will issue an API call to Vault based on the role, and this is when we spoke about the actual roles in terms of the permissions that the application needs and everything. Vault knows that this Kubernetes cluster is trusted, and actually, you know what? Let me take a step back. I just want to describe how basically everything works in the backend between Vault and Kubernetes. So the way that we set up that authentication backend, on Vault side, we're creating a dedicated role for the Kubernetes cluster. That role needs to contain 3, if I'm not mistaken, parameters that needs to be included. First one would be a JWT token. If you've created a service account before in Kubernetes, you know that it creates a token or a secret by default. That secret contains a JWT token. JWT is basically JSON web token. It's a base 64 encoded string, pretty long, that eventually it converts to a token. It needs to have the CA certificate of your API. So I'll get to the flow in a second. And the last thing, it needs to know the service account name that you're using to authenticate from Kubernetes to Vault. Now, what happens in the backend? I don't know how I didn't think to put that in a slide, but I'm just gonna describe that. So basically, when you use your service account in Kubernetes to access Vault, that service account is using the JWT to get to Vault through the API. Vault, once he gets that request, contacts on a different tunnel back to that Kubernetes cluster. That's why it needs the CA, because it opens another HTTP request to the Kubernetes API and says, hey, listen, I just got a request from that cluster with that service account and that JWT. It seems legit to me. I just want to make sure that you're the one that actually issued that request. Once Kubernetes responds and says, yes, I did that, Vault will actually generate a dynamic, or basically based on your set of rules, Vault will generate an access token back to that Kubernetes. It will respond to the initial request, basically, with a client token that gives you access to read the secrets. That's where the init container kicks in. So I'm moving back to the flow. Basically, we're issuing that same API call, the initial API call that I just described. Vault, once it authenticated the validity of this request, it will return a JSON object that one of the keys in this object will be a client token. The init container gets that client token. We're using a bash script that basically uses a JQ command to parse that JSON, take only the token field that it needs to take, write it to a file that is in a shared volume for the pod. It's basically a volume of type empty-dir. And then the app container, once it spins up, it'll just read that text file using an environment variable that we're giving. And the app has access to Vault to get the credentials that it needs, and we're done. The good thing about it, the simplicity about it, if you remember when I mentioned earlier, we're changing the credentials to our databases every month. We're talking about more than 100 passwords. All we have to do once this change was rolled out, gradually restart the containers, and basically they will pick up the new credentials. So it makes things a whole lot easier now. I think that this is the last of my slides. Oh, no. OK, so that's just an example of an init container and how we're using to implement it. So on the left here, you see a full, basically, deployment file that we have. It's, of course, a generic one that I just created for the sake of this demo. So we have a main app container that what it does, it's simply a busy box that sleeps with a just waiting for you to drop to a shell or whatever. The interesting part here is the init container. This is what I focused on. This is where the magic happens from Vault perspective. So it's a Docker image that we have built. This is why you see the image is you're not going to find it in Docker Hub. It's only in our internal repository. That image only needs to get the Vault address, the API basically to interact with, the Vault role. The way that we have generated it, we're using the namespace as a Vault role. And the Kubernetes mount path, this is the path on Vault side. So that's basically the name of the authentication backend that we have created. We just named it Kubernetes. So yeah, this is basically all the init container needs in order to run properly. There will be a bash script, a Python script in the backend that would generate all the API calls. And eventually what it does is to that volume mount named Vault token, which is mounted on var secrets, it's going to create a file that contains the token to access Vault and read the secrets. So yeah, this is really it this time. Yeah, so any questions? Yeah.
Are you using a Kubernetes job or not?
Yeah, so this is part of our CI/CD pipeline. Basically, all we do is trigger. We do everything on Jenkins. It's our central CI/CD infrastructure or component or application, whatever you want to name it. So once we got to the point that we need to start gradually changing the passwords, we will just trigger a Jenkins job that does a deployment for us. No, unfortunately not. Okay, anyone else? Yeah.
Here you go.
Oh.
Oh, wait, sorry.
Yeah, we have to. I don't know.
Hello. I had a question about the JWT token.
Yeah.
It's kind of redundant, but what kind of expiration do you codify an expiration?
No, for the JWT, because it's part of Kubernetes, this is when you create a service account in Kubernetes, you don't have to create the JWT yourself. This is something that Kubernetes creates for you.
Okay.
So the JWT itself doesn't have an expiration. Not as far as it's not as far as I know anyway.
Were you isolating access to the secrets for the specific app or the namespace? Like, I guess you probably get the question.
Well, yeah, I get it. So you're talking from Vault side.
Right.
Right now, we don't have that level of segmentation yet. We have the framework in place. Right now, we're just using it per namespace. So basically, we have one Vault role. This is another thing that you have to specify, and thank you for that wonderful question. This is something I did forgot to mention. When you create the role on Vault side, the auth backend, when you configure it, you have to say which roles in Vault are associated with this service account in Kubernetes. And if you're familiar with Vault, probably, you know that these roles are actually the ones granting permission. So right now we have just one general role that gives access to pretty much all the secrets that all of our applications are using, but we do have that plan to start segmentizing based on roles in Vault. So once we have that, it's just gonna be another parameter that we add when we configure the authentication backend.
I think Kubernetes has the ability to mount secrets volumes on there.
Right. The problem with Kubernetes, and yeah, it's in past tense right now. It used to be 8 months ago that encryption at rest was an alpha feature for Kubernetes, which means that when you store your secret, it's base 64 encoded. It's not really encrypted. You can just take that string and convert it pretty easily to a plain text. These secrets are stored on the etcd backend, and etcd was not encrypted back then. Today, it's a little bit better because etcd can be encrypted, but I mean, it's a possibility, but you would still have to, I think, managing secrets in Kubernetes is still not as good as doing that in Vault. So Vault is still better on that perspective anyway. But yeah, that's possible.
You mentioned you were using the empty dir to write the secrets to with the init container.
Right.
Is that correct?
Yeah.
Are you using any type of admission controller to prevent pods and other namespaces or anything like that from mounting?
No, we haven't got there yet.
Okay.
That's a good idea, though. I'm gonna look into that, and might do that now after you mention it. Thanks. All right. Well, thank you, folks.
While I'm getting set up, is anyone else have any decided they're hiring now? No. Any other things to chat about or whatever? The two talks, everyone I think was nervous and went really fast. So Moshe was like, "No, it's going to be like 30 minutes," and it's like, dude. Say again? No. I usually use a threat that I'm going to speak to get other people to speak, and unfortunately, that left you with me tonight. So unfortunately, huh? The K8s. Ever how you pronounce it? I've heard of it, but there was actually a very good, there's a Kubernetes podcast that I think some of the Google folks do, and they did an episode. It wasn't exclusively on ever how you pronounce it. It's horrible open source projects names. And their perspective on it, and one of them was one of the project managers or whatever they're called at Google. And it was very much meant to be kind of a standard / reference implementation, and not necessarily something that you as an end user may take and, you know, kind of cobble together, you know, kind of a functions as a service on top of. It was really, the thought there was kind of like Kubernetes became a standard, you know, put the appropriate air quotes where they belong, and that, you know, there's the Azure, you know, and the Amazon and the GCP, as well as a self-hosted version, that K8s would be something like that, and Oracle, and and that Knative will be something like that, much like running your own Kubernetes cluster. If you're doing it, I feel sorry for you, but you can do it. That kind of running Knative yourself would be an option. But the set of APIs and primitives that it provide would be a standard that other vendors would hope to adopt. That was kind of the gist, kind of from a non-technical level, is what the product manager was talking about with that. There's been several kind of fast things that have come out on Kubernetes. Some of them are just really weird. Like you put your Python code inside a config map, if you've seen some of those, and it's like, that's probably, I'm sure that looks great in demos, but and whereas Knative, I think it was a little bit more like image centric. So I guess that's interesting. But my guess is it's probably a ways off. It's like a lot of those things like Istio that we'll talk about just a little bit, that, kind of start as, kind of one of those science experiments, and sometimes they work out and sometimes they don't. So I'm interested in that. Are other people even on-prem, doing by themselves, or using a cloud provider, actually using, we'll say serverless, why not? We'll get all the buzzwords in. So you want to chat?
So I'd actually say if you check out the cast from Google Next this year, T-Mobile, we had a demo where we worked with Google hand in hand, and we have a couple things that are running on Knative to date. Very, very, very edge case type things. I will reiterate,
Okay.
But simple web-driven type functions that are very easy. Like they were net new applications that were very easy to target and very easy to develop in time for that. But it is, and we have a hybrid approach, but the majority of our clusters are on premise. So it's definitely something we've been looking at, and it's that balance of, I think you're going to see a lot of other companies that are building solutions on top of Istio, on top of Kubernetes as a base, on top of Istio on Kubernetes as a base, and then eventually on top of Knative on top of Istio on top of Kubernetes.
Is it as big a pain in the ass to run as it looks like?
So there's two approaches to it. If you want to just download the 64 individual YAML manifests and throw them out on a cluster and not care about what it's doing, it's very easy. If you actually want to understand it, and like some of the stuff we ran into, we deploy all of our Kubernetes monitoring stuff in a namespace called monitoring. Knative wants to deploy its stuff in a namespace called monitoring as well. So there's some different things what we ran into where we have quotas. They don't like quotas, and different things like that. So it's a lot of stuff condensed into curl this URL and pipe it to bash. So if you're brave in a non-production lab environment, go at it.
Do you think maybe one of these meetups upcoming, you might want to give a talk or something, or someone on your team?
Possibly. The rest of my team is in Seattle, but yeah,
we can promote
something we can probably work out.
Yeah, we can figure that out. It's just like say, obviously Emmett mentioned, that he's interested. So, and after you see me speak, you'll be like, dude, I can totally do that.
Do you want more random questions?
Yeah, let's go with more random. I'll admit, I'll give you the preface here, just because I had this demo lined up, which was actually where most of the time was, and naturally, whenever I got here and Alex and I were kind of testing out, it just totally bombed and nuked my local Docker thing. So that was half of my talk was this demo, and I'm like, yeah, let's not do that. And he was like, at least it did it now, and I'm like, yeah, I guess so. So that's the reason why I have 10 slides, and I can ramble as long as you want, or we can ramble together, that type of thing. So it's just really about that.
I've got one I've been loving. Would love to ask the group. Is anybody doing pod auto scaling using custom metrics? Anything other than memory and CPU?
We had a presentation.
Probably
it was a while ago. Yeah, it was.
Yeah. But that was kind of before it was officially supported.
Yeah, it was. It was their own thing called Halyard, I think is what they called it. Yeah. It looked really interesting, and we asked those questions.
Because we want to scale off queue latency, or request queuing. Hmm? Yeah, it's right. It's there. We see it's there. I was just curious to see if anybody's used it in anger. You know what I mean? If it's really ready.
I know GCP in their GKE thing now has in beta like that as, so you don't have to worry with, you know, it has its own Prometheus instance and some of that, which is kind of weird in some ways, you know, but it's kind of one of those is like, I've seen plenty of demos, but no one running it for real.
Exactly. We'll let you know how it works out.
Yeah.
Here.
Damn it, Alex.
So I made like a 80% of a POC for this. So basically you have to make an entry in the API aggregator, and then you point it at a service running internally that is basically like a shim in front of whatever your metrics server is that'll respond on certain endpoints. So Datadog actually has like an alpha level project out there. It's on Docker Hub. It's like a Datadog metrics server, but there's like no latest tag. They're like tagged with branch names and stuff. So, you know, it's like super alpha code. And I can kind of get it working. So there's native stuff out there to do it. We're just kind of hoping to find somebody who had taken the step into prod before we do. Yeah.
No, we're fine.
Anybody else?
Go for it.
Any questions?
Speaking of Knative, I heard of this project recently. It's called RIFF, RIFF, like RIFF is for functions. It's supposed to be like serverless invokers for your functions. And I did a quick test, and when you run it, I was just wondering if anybody else has ran it as well. But when you run it, it basically deploys with Istio, and you can define your own function invokers. And then basically just auto scale these like serverless functions, as they're calling them. I was wondering if anybody else has looked into that. I think Knative might be built on top of that, but I'm not sure.
There's one called stupid. Sorry. There's it was at KubeCon last year before last. FN, serverless functions. It's of course an Oracle product now, so fucking sorry about that. But it's actually not suck, and you can actually, it's one of the good things we actually do actually. You can run in your own cluster. It does the same thing. You bring your own containers. It basically has two requirements of what port you listen to and how you handle the call that comes in. But otherwise, you can use whatever language you want, just bake it into a container and deploy it, and handles all the scaling, routing, and everything like that behind you too. So it's another one you can look at too for that kind of stuff. FN. It's full. It's all open source and all that stuff too. So it started off that way. So it's all out there.
Kubeless is the big one in that space, isn't it? That's when we put the Python code in.
Yeah, Kubeless is the one that you put Python or Node code in a config map, and the
FN,
magic happens.
Yeah, the FN stuff is actually going to become our Lambda / cloud functions / whatever Azure has product for that kind of stuff. Most anything is cheaper to use than Lambda, from what I understand. Yes. If you don't build your Lambdas right, yes.
So it sounds like maybe not next month, because we do have a couple of speakers for next month, regardless of what Dennis told you. But maybe one of the later ones we could actually get some folks to do some lightning 15, 20-minute talks about serverless stuff, even if it's not something like if someone wanted to grab, you're talking about running Knative for real, if someone wanted to do Kubeless or something like that, let us know. Or whatever it is.
I'll do it. I'll
Steve
do that for
does.
one. Yeah.
All right, anything else? All right. All right, and I'm gonna do it Alex style and not do presenter mode, just because I tried it earlier and it didn't work out. All right. Speaking of things that if you deploy the 64 YAML files and it works fine, but if you actually want to care what it's doing, we have Istio. And really what I was like I have call it an introduction to Istio, but it's really, since my demo did not work out as we discussed earlier, it's a little bit more about service meshes in general. Than like kind of at the end I can ramble on about how it actually works with Istio, since I don't have nice command line prompts and everything to show you that with. But one of the interesting things is like Istio, people just assume it's actually a CNCF project. It actually is not. Now, what's the actual meaning of that? You know, like for actual users, it's probably not, but Istio is actually owned in open source is kind of a weird thing or whatever, but it's primarily like Google, IBM, and Red Hat, I guess, are the two owners. But the interesting thing is you do have things like Knative built on top of Istio and then several other projects. My interest in Istio is, you know, beyond just my own morbid curiosity with train wrecks, is just having in the past like implemented what it does several times on my own, and the fear and loathing and hatred of yourself that comes from doing that. So it's kind of interesting that the community as a whole is coming around to do those type things. We'll talk a little bit about that. Istio, what was it, 3 months ago, released 1.0. 1.02 is out, which is bug fix releases. It's kind of interesting. 1.0, they actually have a list of known broken things, and one of them is actually one of their most highly touted features, which is you can extend the mesh from beyond Kubernetes to VMs as well. It doesn't work, and they actually have it as a known. And I get the sense that we have people here who actually know a ton more about Istio, so they're going to keep me honest and call bullshit on me. But really, like, say, more of me is like more of an excuse to kind of look into this and everything. And anyway, so about me, if you don't know me, I've been doing this Kubernetes thing for a while. I have a committers badge because I actually committed like 10 lines of bash script like back in like the pre 1.0 days, but I still get to vote. Damn it, still counts. Yeah, and I guess before SRE had a name, you know, that's what I did, and that's my official title now. So yeah. So what is Istio? Istio is an open source implementation of a service mesh, which leads to the question that everyone says this when you have buzzwords that are recursive, like, so what the hell is a service mesh? And I would say that if you have a monolith, you know, whatever language it has to be written in, that everything we're going to talk about, you're like, I don't have to worry about those things. That may be a lie, but, you know, you can at least, you know, in a good sense, you know, go to bed and sleep well at night and tell yourself that lie, which is fine. But as soon as you decide that I want to break this piece of functionality, whether it's new or old, into its own service, you start to have to ask yourself these questions. And really, so what we're going to talk about some is what a service mesh is. Even whenever you hear all these buzzwords and all these kind of like, these sound really important, this is really the questions that we're talking about whenever we do this. And if you read these are just very simple things. And just think about two applications that need to talk to each other. So what we have, and like I said, this is pretty short, so we're gonna, you know, feel free to interrupt and heckle or whatever, is if you have two services running there, you have to somehow figure out how do you talk to each other. Like, and back in the old days, the easy way to do this was like, oh, I'll just hard code some IP addresses in a file. That's not terribly, you know, dynamic, but, you know, depending on your what you were doing, that was fine. Then a common pattern came to be, I know we'll put a load balancer in between there and we'll just point it in. And the only people who really liked that were load balancer vendors, because, you know, you just really never knew what was going on. There was all this stuff going on in this literal black box often, that you didn't know what was going on. And then you had various other tricks that somehow I'll ask a DNS and I'll look up, you know, certain record types, you know, A records or TCP or whatever, that type of thing. Or I'll ask some bespoke system. And then, you know, around the same time, at least in the open source world, you had things like Zookeeper coming out, you know, if you remember one of those, and it was Dozer, which was the one I think Heroku released. And, you know, ultimately you had things like etcd console and all that sort of stuff, which was basically, here's a simple API that things can register like, hi, I'm doing this thing. And anyone who wants to like ask me about that thing can come figure out where I live from that. Very basic, like say, we put nice big words like service discovery, but that's really all it is. And then Kubernetes, what that kind of grew into was Kubernetes had a well-defined API, and you could ask it what endpoints are running this service. And that's really the API calls, if you look at it, are not that far off from that. And you'll get back a list of IP addresses and ports for that. Or you can actually ask it DNS questions, which is actually backed by the same API. So that's really one of the things that when we're talking about service mesh or whatever, that's what it is. And so that's one of the things that Istio does. Istio, I'm somewhat assuming in here that we're talking about running Istio on top of Kubernetes. You can run it on top of other platforms, but yes, Kubernetes Meetup. This is not the console Meetup. Our Raft implementations work. And I was at CoreOS for a while, so yeah. It said, are they available to talk? And this is one of the reasons why back in the day, why we put a load balancer in between things. Because like, if you remember back in those like nice 3-tiered applications back whenever everything was written in Java and used large database vendors for their databases. You know, you had these nice big iron load balancers. And one of the things they could do, they could health check. So they would just, you know, every 5 seconds ask every server behind there, like, hey, are you still there? And like, yeah, I'm still there. Or, you know, like, no, I'm not, you know, and if you said you weren't for 3 times in a row or it timed out, you would get removed from the pool. And that's what's kind of known as active health checking, if you want to use the buzzwords, which means I'm actively asking things, are you still there? Then we have this idea that, and Nginx, those who've used Nginx actually have this whenever you do the proxy rules. It's like, you can say, if I get more than X number of 500 responses from this server in X amount of time, I'm going to mark it as bad for this many seconds, right? If you've ever done that. So what that would mean if like I sent a request to this server, returned to 500, and it did that 3 times in 10 seconds, so kind of sliding window, I'm going to like put it in the penalty box for 10 seconds and not ask it any more questions. That's the very simple definition of like circuit breakers. If you've heard, you know, which is a pattern. It's the simple version of it, but that's kind of the way it works. And that's what's kind of known as passive health checking, is I'm going to observe traffic as it comes through. I'm not actively asking anyone. I'm just going to observe what's going on, and then I'm going to decide if things are up or down. So that's one of the things that Istio gives you. And one of the interesting things that it will also do, and we'll get to why it does this later, is if everything gets marked down, it will actually, what do you do then? You know, do you assume that something's wrong with you if you can't talk to anyone? So that's actually one of the things that you can do, and when you're configuring this, is you can say like, if more than 75% of my things I think I'm supposed to talk to are down, I'm probably the problem. So, you know, assume everyone else is up. I'm not saying that's the great assumption, but, you know, I'm just saying that's the way it works. If you look that up, it's called a panic threshold. One of the other questions when we're talking is like, so now we've got these things talking to, and remember back in the free days when everyone had that nice big firewall sitting on the outside and you just trusted everything that was running behind it. And then you found all your credit card numbers on the internet. Then you said like, I want to actually make sure that the service that I'm talking to, that server that's running that application, is actually who I think it's talking to. And then on the other hand, is that server is going to actually say, are you who you think you are? Or who I think you are, rather. And so that's where you get into like, I'm going to do some authentication. Like, you've got to have some credentials to talk to me, and then I'm going to actually verify who you are both ways. And this is where you, the typical way that this is done, and the way that Istio does this, through mutual TLS. What that means is I can verify, because we both trust a third party, that you are who you say you are, and I am who I say I am. So that's why if we meet each other, that we exchange credentials, you know, in kind of the ID sense of the word, that we're pretty sure we know who we're talking to. So that's one of the things that it does as well. And then another thing that you can do later on top of that is you can say, you know, are we actually allowed to talk to them? And this may not just be I'm allowed to talk to them, but I'm allowed to do this certain action. You know, that may be something that I'm allowed to ask you a question, but I'm not allowed to tell you to do something. Like I can have, you know, effectively read-only access. That's what authorization is. So, you know, like not only are we pretty much trust each other and know who each other are, but I can ask you to do something and you can tell me whether or not, you know, I'm allowed to do that. So that's another thing that we can do in there. And another thing we say, like, how long did it take to talk to them? This is another thing, is once you started crossing network boundaries, that, function calls weren't local, not that they were ever finite in time before, but now particularly when you have this variation of the network, because, regardless of what people tell you, the network is not reliable, is you just have this compounding problem of, like, how long do things take? So if you have a failure on the networks, you actually get this interesting, exponential back off, which is always fun whenever that hits you. And so that's where, like, metrics around things like how long does it take to make a network call? How long did that, remote, procedure call take, become very important. And it's not only do I want to time individual calls, but then I want to see what does that complete call graph look like for an individual, like, end user who comes in and hits my front end web app. And, I've, drank the Kool-Aid and have 3,000, microservices. I want to see exactly how they traverse through my stack and be able to look at an individual kind of, incoming request and trace it through there. So that's one of the things that we can do with this as well. Which, depending on who you ask, for some people, that's actually kind of their primary, like, kind of debugging tool. If you have really good tracing, it in some ways takes the place of a lot of these other kind of traditional things, sometimes. And then it's like, we want to tell someone that we talked to them, like, we had this conversation, so I'm going to write it down in a log. Sometimes that's for just, like, I just want to make sure in case something is wrong, I can go look at it. But there could be compliance reasons. There could be other reasons for that. So that's whenever you hear, like, the service mesh, really think about it as these are the type of questions or the type of task we're talking about. And people have been doing this for a long time. It just, in the last few years has come up with this name called service mesh. And so that's where we can map these kind of very kind of normal, like, questions that we have about operating distributed systems. Because once you have two systems, you have a distributed system, whether you like it or not. These are the type things we're talking about, and that's, so don't ever be kind of intimidated or wondering whenever you hear these nice big words about service discovery and all that. And you can kind of map it, kind of the plain English version of that. All right. So kind of, we've said all this, and I've said Istio like a whole lot, but it turns out, like, Istio doesn't do a lot. And TLDR, that is, Istio is just a control plane for Envoy. And Envoy actually happens to be a CNCF project. So yeah, we got our quota in. So why do we talk so much about Istio whenever Envoy's been there? So we'll talk some about what is Envoy. And this is the kind of byline from Envoy. Envoy is a layer 7 proxy and communication bus designed for large, modern, service-oriented architectures. What does that mean? Huh? Yeah. So everything that I described before about a service mesh, various people have taken different approaches about how to do that. If you look at, for example, Twitter actually has a Java library, or I guess they write in Scala, but same difference from my perspective. But called Finagle, that all those things that we just talked about implements it as a Java library. So it's like, oh, I have a service mesh and it's in a nice Java library. But then it's like someone wants to run, and say you're running Java, you might like, I'll just do that. That seems much simpler. Then someone wants to write a Python app in your organization. Like, how do we take everything that we had in that application over there and be able to do that with Python? And the way that people have approached that, and that's where this thing came, that we want to use this out of process architecture. So that means that no matter what language or how your app is written, I don't care, I'm going to run out of process. And that means you're going to talk to me rather than to your endpoints. If you've actually seen what Linkerd is, or at least Linkerd 1, they're going through some rebranding, is they basically took Finagle and made a daemon out of it. All 4 gigs of it running on every Kubernetes node, if you want to see that. But it was one of those, like, the idea, if you want to like follow that conclusion or whatever, that makes sense from their perspective. But what Envoy, it came out of Lyft originally, and they're still kind of the primary, developers, owners, shepherds, whatever you want to call them now. As Lyft is now, I guess now all the hipsters are now back to C++. So it's written, but what that means is it's very lightweight, and so you can run it out of process. And some of the interesting things that came about, and a lot of this was just kind of right place, right time whenever it came out, is this, has native support for HTTP2 and gRPC. Do those words mean anything to people? Okay, some people, yes, okay. And that's probably a different set of talks that we could do about gRPC. And another interesting thing is, if you ever tried to sit down and like read the Envoy documentation, like I want to write a config file for this. Like I want to treat this like Nginx or Squid or whatever, proxy it is I want to use, you will go crazy because the configs are just convoluted and they're just long, and it's either JSON or YAML and they're, kind of nested, and they kind of somewhat have, like Kubernetes, have indirect, metadata type references to other parts of the configuration. Think about label selectors, but imagine that in kind of in a proxy type mode. And you're like, why would you ever do this? And really, because Envoy was not ever meant to be like configured by humans. It was really meant to be what Envoy does. And this is somewhat different. Like you don't talk to it to configure it. You give it something to talk to that will tell it how to configure itself. And so, and it does that either over HTTP 1.1 or it also does gRPC. So you can get like, diffs of configs between each other. That was one of the interesting things about it. It was like it was actually written for machines to configure, not for people to configure. So that was one of those kind of like ideas that now when you think about, and you're in a highly dynamic environment like Kubernetes, whereas Envoy is actually written to run on like a huge auto scaling AWS infrastructure, but kind of the same idea holds there. You've got pods coming and going and everything. A human's not going to go in there and edit it, but an API shim in front of Kubernetes could do that. So that's really, really kind of at the core of what Istio is it's really Envoy acts as the data plane. So like all your traffic that flows back and forth actually all travels over Envoy, not over Istio. Kind of Istio is like this wrapper and all that. And you don't even have to know that it is Envoy, but you have to do that. But your control plane is able to do all these dynamic, wonderful things, or so it looks like. But really all it's doing is providing an endpoint and telling Envoy how to do things. So in the outer process architecture, a lot of people, whenever they think about that, immediately go to like, well, isn't that slow? And it turns out that the majority of applications, like talking to each other over HTTP, is not usually the bottleneck. There's usually somewhere in your stack, there's something that has actual disk associated with it, or some huge computation. That's usually the slow part. So yes, in micro benchmarks, yeah, you can prove that this is 5 milliseconds slower or whatever it happens to be. But in actual kind of day-to-day usage, that's going to be dwarfed by anything else. All right, so why do I need Istio if I want to do this? That's one of the things we brought up before. It's not language dependent, and it's not just like because most places tend to have one language they support, but there's always that outlier service or like this third-party thing that you're implementing. So that what it does is, and also a thing that people don't think about, what if I need to update my service mesh, my library, if it was everywhere all at once? If you're running on Kubernetes, like we were talking about earlier, oh, I've got a Jenkins job that restarts everything, that's probably fine. But, depending on what type of environment it is, you may just want to be able to update the rules in that without having to restart everything. So that's one of the things that kind of being outer process and not being tied to a particular language, framework, architecture, or whatever is able to do. We mentioned before something about the kind of proven data plane, which is running on Envoy. It's one of those things. I remember back in the past, one of the ways that we did this was with HA proxy. How many, if you did that back in the day, this was, I don't know, 8 years ago type thing. And HA proxy was really fast, but God help you trying to get metrics out of it. And that was one of the things that Envoy does, is it is heavily instrumented. What's really nice to be able to get complete timings about, everything that's going on for each individual call in and out. So that's one of the nice things. And that's one of the things I'd say, like, sure, all of this, you could probably build part of this yourself, and have fun. It's just, as soon as you need to add that extra feature to it or whatever, you're slowly going to be reinventing your own version of Istio. Even if you started with Envoy as your base, and I know this from having done it myself, starting with Envoy or whatever, you kind of slowly evolve into at least some subset of the features of Istio. but it's usually you and maybe a few other folks doing that. One of the things is, like, since we are talking about Kubernetes, is that Istio uses Kubernetes custom resources, CRDs, to actually to be configured. So you manage it just like you manage other things in your Kubernetes cluster. So if you're deploying, we're talking about deployments and maybe services and stuff, you can actually deploy routing rules. Those circuit breaker rules like we were talking about earlier, you can deploy that along with your application at the same time. Of course, it's using, Kubernetes native APIs to do all that. Built into this is metrics and log aggregation out of the box, kind of Istio. It's just a flag to turn it on. It will present Prometheus metrics so that you can scrape those using Prometheus or something that is compatible with Prometheus. And so all those metrics that we're talking about that you get from Envoy, you can actually do that, and it will actually show you, you'll get labels on each metric. So you can see, like, service A called to service B, it got this response this many times, and these were the timings around it. So that's pretty nice to do. And you kind of get all that, kind of for free. And log aggregation is the same way. Since it's running out of process, depending on what you're running, you may or may not have the same logging framework going on, but you can always make sure that your service calls between each other, both on the kind of server side and the client side of that, if you will. You can have, kind of a standard logging pipeline that goes through there, which is sometimes very interesting whenever you're wanting to do introduce some kind of resiliency into, like, kind of a self-made service-oriented architecture, and you can introduce something like Istio without kind of having to dig deep into your code, because you can get a lot of this just by injecting Istio into there. And tracing support, that's another thing that you get, is that you can do request IDs and get all the trace IDs, and it will flow through the system, once again with in the case of tracing, there is a little bit of code changes you have to make. You have to make sure you propagate headers, but other than that, it's a fairly cheap way without kind of having to open the hood of everything and do kind of a complete rewrite to get, kind of this pseudo black/white box monitoring from your applications. All right, this is a very confusing slide because this is where I was going to jump to the demo. So I'm mostly going to talk about a little bit about this. This was actually a slide from another talk that the tweets there that I thought was actually good. But there's actually, I was going to talk about and then show these, and then it doesn't work out. There's really three main components to Istio. Unfortunately, since it's Kubernetes, there's just so much YAML that you have to do this. We talked a little about Envoy. We're not talking about that. We're talking about really the control plane. But one of the ways that it does this, instead of injecting a init container or a side container, like we were saying, that you're actually putting into your deployment resources, like we were talking about with Valult earlier, is what you can do in Kubernetes is you can set up, you can actually have, say, whenever this type of resource has this action, in this case, I want to create a pod, you can say, I want you to call this webhook. And so what that webhook is ever able to do is say mutating mission webhook, if I recall, like, is it will receive a pod kind of as this body, and then it can decide to do something with it and then return back, this edited pod manifest. And so what Istio will do is one of the components of it will do is receive that and then spit back, that with an init container injected into it and a sidecar that is running Envoy, and that Envoy is configured to, talk to the control plane that we're talking about. And if you have mutual TLS enabled, which we kind of glossed over earlier, it will actually set up, the right, kind of base credentials to get that going. And so the thing is like, then you can do that without kind of having to edit your base application configuration. So there is this idea that you can kind of step into Istio. And everything we're talking about with Istio, everyone kind of talks about it as this kind of like monolith, if you will, this kind of big hole, this hole, but you can actually kind of pick and choose the parts that you want to use. Because Istio acts not just as service to service, but you can also act as an ingress. Remember, Kubernetes has a standard ingress resource type, and then you have like the 18,000 different implementations thereof. Istio actually took a slightly different approach to that. Earlier versions supported the default Kubernetes ingress, but now they actually have their own idea. They call it a gateway, which is actually more, I guess, talking about north-south traffic versus east-west, if you're familiar with that terminology. So you could actually install Istio and only do that and get, metrics and logging just for that part. And you could also only install it for the services service. And with all those, you could do that with or without mutual TLS. And so there's basically 3 different parts. There's Pilot, which is responsible for service discovery and traffic management. It's kind of odd to me, some of the pairings that they have in these components, but I suppose, some of that is historic, as things grew up. There's a part called Mixer, which primarily does access control and telemetry collection. Those are 2. I don't really know why they go together, but I'm assuming there was some reason early in the life cycle of that they went together. And then it was the part called Citadel, which does end user authentication and is responsible for a mutual TLS. Is kind of for, like, say, once again, if you do the demo, like I'm going to download the jumbo YAML file and apply it. None of this really matters. You're going to do the demos, which I didn't do. And you're going to do that, and you're not going to look at it. But if you really care about, like, kind of running this at production and everything, you're going to want to look at a lot of these, because it is one of those things, like, if you're not doing mutual TLS, you're probably just not even going to run Citadel, and depending on what you're doing the other things, you don't have to run the ingress part of it, the gateway part of it. And in reality, you can do this. There are actually multiple plugins. And since it's Go, they're all built in. But, like how you present metrics, there's 2 or 3 built in. There's a Prometheus one. I think there's a Datadog, and just a plain StatSD one. And same for logging. There's, I want to log the standard out, and there's a couple of other of those. So they've been trying to somewhat play nice within the ecosystem with those things. And at least at one time, in theory, you could change out the data plane, but I don't know if that's even practical anymore. Is it works? Yeah, interesting.
It does change things.
Yeah. Yeah, because that's one of the interesting when I started looking at Istio, because I came at it from being an Envoy user. It was like, oh, this is a better version of the crappy thing I wrote, So it'd be interesting, like, how that works with Nginx, and which version of Nginx, the one you pay for or the other one? Yeah. Sorry, I have to dig on them because, sorry, they did some weird things. All right. That's kind of like, say, I kind of like expand a little bit on that since I didn't have much more to say. Any questions, discussions, or whatever on that, or anything in general? You got to throw the box at him, Alex. Come on.
Watch out. I almost killed this guy earlier. Watch out.
Oh.
I was wondering about anyone using it, particularly for the gateway piece, right? More traditional ingress to the cluster, API management use cases. I know it's emerging in the.
We're using Nginx
Yeah.
for our ingress controller, but we're also a big pivotal shop, so like Pivotal Cloud Foundry, Pivotal's roadmap shows them dropping in Istio with Envoy in front of what's now been rebranded as Pivotal Application Server. So you'll have that with K8s, their package Kubernetes offering. They'll actually share that routed gateway space between the 2 offerings, called Istio and Envoy. So not something that's there today, but they're definitely looking at it, kicking the tires.
It is similar in the OpenShift is looking at or replacing their router with HA proxy implementation with Envoy for as ingress controllers.
It's definitely from our look at the industry, it's going to be around. You're going to start to see it pop up more and more. So it's becoming a fundamental building block for a lot of it.
Yeah, and I think one of the, we were talking about Knative earlier, the fact that Knative just built on top of Istio what I think interesting, because a lot of the other things in that space had kind of went and done their own thing. So it was kind of very telling that, that went down that way. Go for it.
I'm kind of interested so I want to use it like for the exact opposite reason. Like if I have like Nginx Ingress set up, I would be really interested to see what the like stack tracing monitoring data says between like all the microservices. Is there any reason that I wouldn't be able? I know you said that like you can only have 500 Envoy sidecars, so that's per pod, right? So like I can run 500 pods. Is there any other like reason that I wouldn't want to do that?
There are some limitations around the scaling for the number of routes that you can have.
Right.
Now,
The routes.
not the number of pods. So it is loosely coupled to the number of pods, but
Yeah.
I think you'll start to see that number go up. Like that's just where they started and everything. You will start to see it go up. It's just as fast as they can.
Yeah. One of the things shortly after 1.0 came out, there's a document actually floating around. There was a huge kind of deep dive into the performance around Istio, Envoy, and all that. And if you go search around, you can find it. And it's actually pretty interesting because now that it's kind of out there and becoming big, like lots of people are paying attention to that. Whereas kind of prior to 1.0, it was really more about functionality. So I think kind of that concern or whatever is being addressed kind of post 1.0.
Yeah, and I know for us, like we're looking at it, we're using it in some spaces, but for us to like fully adopt it as from an ingress perspective as our primary ingress, we're waiting on things like TCP, UDP, in addition to the HTTP 1.2 and gRPC functionality. We want to be able to host all services behind it, not just specific services that are accessed, via HTTP or gRPC. Because if we open that up for this application, the next developer or development group that comes along is going to say, well, we want that too. And it's like, well, your service, operates different. You can't do that. So it's a, status symbol almost amongst developers.
Istio?
Just, yeah.
Yeah. And we didn't get into that. Istio can also control egress traffic. I've never ran it that way because it becomes a big pain in the ass, but I think that's one of the things is being able to lock down our other ways, like what your pods can talk to outside the cluster as well. And then one of the interesting things it does there is not only you can do offload TLS, but you can do some interesting things with like, I'm going to actually rewrite what you're talking to because maybe there was some weird API incompatibilities or something like that. So that's one of those that you almost always see if you go on mailing lists and look. Everyone's like, did you check this? Yes, turn it off. Any other Istio or just general Kubernetes things? If not, we'll once again want to thank our hosts. Like say in October, and we'll get it out soon. I just had to confirm some stuff today that in October we'll be at Full Story, which is right near Sweetwater Brewery. If you happen to, want to make a day out of it or something. So we'll be there, and we do have one speaker, which will be kind of a longer talk, and probably one lightning speaker, and we may be able to squeeze in one other. And if you haven't noticed the way that you always see as the week leading up to the meetup goes, we always immediately say, would really be great to have some speakers. It's usually because someone's like, I can't make it because real life intervened or something like that. It's a meetup. We're doing this on our own time, type thing. So I'm totally that. So if you had that talk that was just burning, you might get a chance in October. Like I said, if nothing else, I hope that, you can all see like what we three who talked here kind of took something and just talked with it. So don't feel like you've got to be well polished or this or that, because sometimes like someone kind of rambling on for 10 minutes about this thing that they did in production is much more useful than like some of these really, kind of a well polished like conference talks, because we know each other, we hang out together and all that and get to know those type things. So, so just if you ever want to talk and want to do, suggest a topic, or a theme or something like that. It sounds like some of the serverless stuff is interesting and all that. just let us know. Just make a comment on there, and we'll try. Like I said, we've had a real hard time with venues recently, but I think we've got a couple of places going well. Yeah, it really sucks to have your meetup canceled because the venue backs out on you at the last minute. So anyway, I'm rambling on now. Any other comments? If not, then I think there's more beer and pizza.
No